12:49, 20th of January 2012. It's funny. My 8-year-old niece was celebrating on the phone with me because there's a snowstorm tomorrow in Newfoundland, St. John's, Canada. And I went to look at the satellite image on Weather Canada, and I clicked on it actually once, twice, then I went to the third image, and I was like, why is half the data missing? I mean, I look at the infrared and then the visible and infrared first, but when I look at just the visible image, I'll show it to you. It's like, why is all the data missing? For a split second, I thought it was a data problem, but clearly it's not, because it's like sunset. You know, it's 12:47, 12:49 here, and sunset today in Phoenix, Arizona is at 5:47, and it's exactly 5:47 right there in Arizona, and that's why it's dark, because that's nighttime, and obviously there's no visible satellite image at night. It's like, it's just, I had to render it twice to kind of come to that conclusion, and sometimes my brain's really quick. Like, I passed a bottle of oxygen in the hospital back to my Band 7. He goes, where did that come from? And right away I went, it came from the triple alpha process and a supernova, basically a star exploding. And I was talking about the cosmological origin of oxygen, not the little miniature cylinder that we were using, and he was like a bit floored by how abstract I was being, but quick and witty. So, without talking about myself, like, there's an app on your iPhone for Starfinder, and I just did it from my flat. And we'll look at the sun and the moon and Mercury, which is the fastest planet. It has an orbital time of 88 days, and Saturn, which has an orbital time of 10,760 days. So right now, when I did this last at 12:37, the sun was there in my flat, and north is roughly there. So you can see that if the horizon's straight ahead, we got to look down. The sun is just below the horizon, and it's set just over there. So the plane of the sun is down there now, and it's going to rise this time of year. In the summertime for me, on June 21st, I have an angle of the sun where it rose at exactly like 8:21 up there in that window. So the sun is setting really far north right now, up in this direction, but in the wintertime the sun is rising down here. So the plane for the sun is down across here, if that makes any sense. It's hard to get a feeling with how dark the video is and my lack of, excellent. Mercury's right there. The moon is there right now, and it's going to rise obviously in the same place. And then Saturn is actually, Saturn is up here. Saturn's the slowest planet, and when I do this video again at the same next year, because Saturn has an orbital time of 10,076 days, on the 18th of January at 0037 roughly, Saturn might only just be there if my data is accurate. And I did it 3 times to get an accurate position of the planets, because you think about it, in 365 days, that's like, how many times is that? That's say 3 per thousand, 30. That's like 1/30th of its orbit. So 1/30th of its orbit is roughly, how many times does 30 go into 360? It's like 5%. Well, obviously 10 is 300 plus 2, so it's 12 times. So 1/12th, and then 1/12th of 360 degrees is roughly like 8 degrees. So I guess maybe in a year Saturn goes 8 degrees. So next year, on this day, if my data is right, and I'll check it again, once we after several days of data, once we know where Saturn is now, next year I believe Saturn will be roughly right there. So the plane of our solar system, if I use my torch, is like this roughly, and then setting down there, and the planets are down there like 30 degrees below the horizon, and then we're above the horizon like 60, 65 degrees, and 30 below. So I'm kind of laying out. And that's interesting that it's like basic astronomy in your flat. So I want to talk about the planets. But did I have to go back into my flat? Oh yeah. For example, in my hallway, down right here, now if you look that way out the window, on exactly June January 15th at 3:14, the sun was exactly up in that window. If you did this in the daytime, I could show you that. If I bring the camera ahead, I'll show you where the sun will be. The sun will be exactly right there in my window. That will be the sun. So if we did this on January 15th at 3:14, and I put my camera right here, that would be the sun exactly right there, because that's where it was on that day. And to the second, the sun is in the same place a year later, because I've been doing this for the last few years, because I have an accurate time source. If you look at my watch, you know I have a radio-controlled watch, which gets exact time from the French Institute of Weights and Measures. You know, it's the atomic time source. So the website for atomic time is bipm.org. See, bipm.org. And here's the time right now. If you watch it, I'll call it out seconds. 57, 58, 59, 0, 1, 2. So you can see that I'm almost in sync exactly, because that was my watch. You can see it's out by like a tenth of a second. You can watch my phone. I'll call the seconds on the screen by BIPM 15, 16, 17, 18, 19, 20, 21, 22. So you can see, let's say and it says your estimated transmission delay is spot 09 seconds. So, and I'll show you my YouTube video, and you can look at it yourself. And in the replies to this video, I'll give you the link. So, the video is called The Sun, 3:14, 7 seconds. And look, there's the hallway, and there's the top corner of the window, and that's where the sun was. So we'll do this video a year from now.
Exactly in the back window, which it rarely does, but it hasn't yet touched the front door of the house.
And it only touches the front door one day a year. And I believe that this was 25 days before the equinox, and I didn't write down and film it when it did that, but I believe it with a bit of classical physics and a bit of a website, I could work out my best estimate for which day next year the sun will hit my door, because it only did that one day ever. The sun came right along the hallway right here, and it rose up and it just touched the direct of the door. And I went down here to the door with my eye, and I could look back and just see the sun. So that's very accurate to where the sun should be one day in the future or the past. And I'm not sure how to work out what date it's going to be, because basically your stone is like Stonehenge. I mean, your house is like Stonehenge. Because if you start to be mindful where the planets are, like imagine like in the Dark Ages when we didn't know the topology of the solar systems and we started to follow the sun and the moon, and you had nothing else to do. But here, I have an accurate time source. But imagine like in Neolithic times, well not Neolithic, say like 5,000 years ago when Stonehenge was put up. You start to read about Stonehenge and what it could be for, or other kind of stone structures around the world, when you start to know the history of astronomy in terms of what was known about the phases of the moon, like the rhythms of the orbit, because every orbit has little idiosyncrasies, little kind of wobbles. Like Mercury has an oscillation, like oh yeah, I got a little thing to make the oscillation. So I didn't know. Shit, I gotta get my torch. This is great. Before 10 minutes, I gotta finish the oscillation of the orbit of Mercury, which couldn't be explained. But I can't really. Here we go. I can't really explain how this elliptoid orbit kind of oscillates to make like a daisy. If you picture like, I didn't know why I had this set, but I think that we can make the orbit of Mercury. I gotta lay the camera down and get my tape out, because I gotta keep the paper still while I film and hold the camera and talk to you at the same time. And I was gonna throw this out years ago, and I didn't, but now it finally comes into a purpose. So basically, if we put, how do we make this orbit? Where do we? I'm not sure how to use this because I've never actually used this before, if that's believable. Let me do it right here. Okay, you get the idea. maybe I didn't stop where it ended, but basically you get a wobbling of the orbit. It just kind of makes these elliptoids, and the orbit of Mercury is more like this. I think this is called a phase space diagram, I think. And I'm not sure how many protuberances it has in a 360-degree circle, or what the mathematics of it is, but if I knew that, I could find the exact radius, and then it deals with, I think, the basic geometry is, if you have a line and a chord, and then a third line, then that would, there's a certain ratio to all that will give you the orbit for Mercury, I believe. But I'm reading geometry recently. I don't know exactly like what vocabulary I need to tell you right now that you could make that figure in your head if you're a mathematician, or how much about maths. Like, I don't right now have the vocabulary to tell you, to describe to you what I'm trying to describe, but oh yeah, so that's just about, so imagine just like being like 3,000 years ago and then like working this out and finally coming up with a hypothesis, and then looking at the world and then doing an experiment and having an expectation, and the expectation meets your hypothesis. For example, I have this idea in financial markets about price behavior at certain points that I call points of instability, or that's what Curtis Faith called them, and I just adopted a term. For example, this is gold. This is the daily trend line. This is the 5-minute chart. And I got to show you the daily trend line because there was an expectation that the market would stop there. But then that's where a price reversal can be expected. But then in terms of not guessing and taking the guesswork out of trading, you need quantitative evidence that that level is going to hold. So here it is here. Look, if I zoom out, I don't need to tell you the days, but this is the high back in the summer. 1, 2, 3, 4 days, 5 days, 6 days, 7 days. This was the 8th day touching. And sometimes those points have been perfect. Like these points right here. I got this, oh yeah, I can show you, great. So I know why I make this shit. Like right now I have a little book and I've broken that down for you, and you can go, if you pause this video, pause the video, put your iPhone on that link. It's a twitdoc/Jack Bravo Uncle. That's where this document is uploaded. Because that explains the predictive value. So if we do this in low light, we're looking at, these are daily candlesticks, but we're going to look at gold back at that point. So here we are at that point there. That's like December 2nd and December 8th. And then on this page, we have that test there in the 1 hour chart. But if we zoom in and increase our magnification, I'll show you that point in the past. So here's December 8th. This is the 1 minute chart, I believe. And there's a 5.2% bearish RSI divergence. Now, that means there's going to be a price reversal, but I showed you the whole chart and we sold off like $30 at like 40 bucks that day. But look, if I fold the chart, this is how it would have looked. Look, we're testing it. No, I got to fold it wrong. Look, here's how it looked in real time. So we're testing the daily trend line on December 8th, which is 1, 2, 3, 4, 5, the 6th test, which is strong resistance. So there, the market is expected to hold this course. And this angle, this line is so gradual, it goes across the whole page to here. There's 1 pixel down and it drops down again. So if you know how many pixels were on this chart, you can work out the angle of it and map that to the daily trend line in terms of like the topology of a chart and the algorithms that make and render these charts. But look, 5-minute chart. Is it 5 minute? No, sorry, it's 1 minute chart. Look, it goes from 312 to 324. So there's 10 candles in that space. So the 1 minute chart, the market tagged it, and there's a bearish 5% RSI divergence, and then we sell off. And then we sell off a huge amount. So I'm going to show you that exact same thing today, and the market did it again. The market stopped dead on that trend line with a bearish RSI divergence in the 1 minute chart, but not the 5 minute chart. And that's my video called On the Momentum of Price Reversals in Financial Markets, I think. It's the last video I did. But here's the 1 minute chart. At the 8th test of that trend line this morning, I wasn't up, but look, there's a bearish RSI divergence, and I think I've measured that. I'll put my cursor on it again. It's the only bearish divergence. And I can tell you the RSI at the top is 83.37, and then right there, that lower peak, the RSI is 58. No, I didn't have my chart. Sorry, I didn't have my chart locked, and the next tick count came in and scrolled the chart ahead. So I got to go back and lock my chart to get you that value, because I never got you that value. Because measuring the value is important. That value is 74. So I said it's like more than 10%, right? And that's really significant. And the market sold off today like $20 from that point. Well, if I show you the 1 hour chart today, and you can see how the market held that. Look, the market sold off from 1669, this is the hourly chart, down to 1649. So it sold off $20, and trading one contract, 20 points, is $2,000. So this is like experimenting. You know, you have a hypothesis, and you look at, and then you see their behavior in the reality. Like, this is my experimental approach to trading in terms of quantitative trading. It's the way science works, and all of religion, it then is like dogmatic nonsense. Like, I read this paper that I got, which you can get on my Twitter account 2 days ago. It's Kitefrog on Twitter. It's the turbulence of stock markets, their causes in the Sharia law. So from without making any references to religion, from this person's point of view, basically the whole financial markets are corrupt, biased, you can't get ahead, it doesn't work, it's a flawed capitalist system. It's interesting that this work is the most biased piece of work I've ever done. It doesn't reflect the reality of financial markets. So that's just kind of my idea on science and my place in the world and where the planets are right now, and a whole bunch of shit. Oh, timestamp 105:16, you just saw it.